Hello and welcome to Sir Optics Academy. So let's look at 10 organic compounds and how we can name these organic compounds. We have the names given, and then in some instances we have the condensed structure given. So let's look at how to name the organic compounds on the board. In number one, we have propanol. Propanol. The ONE in this particular structure is indicating the ketone family, the ketone functional groups. For the ketone functional groups, we have RCOR. The R in the middle is double bonded to oxygen. So in any organic compound that the name given is ONE, the suffix of the name given, of the parent name is ONE, then it is an indication of the ketone family. But let's say in a structure, you have carbon double bonded to oxygen, it is an indication of the ketone family. So two things are involved. If a name is given and the parent name of the particular structure ends with ONE, then you have the ketone family. But if the structure is given and then carbon is all bonded to carbon and then bonded to other two alkyl groups, then you have the ketone family also. So it depends on what you're going to do. First thing first, identify what you're dealing with before moving on how to deal with it. In summary, whenever you are given an organic compound, be it the name or the structure, first thing to do is to identify your longest continuous carbon chain. After you have identified your longest continuous carbon chain, the next thing to do is to identify your functional group. Your inability to identify your functional groups will make it impossible for you to know what you're dealing with. It's just like you wanting to deal with somebody and then you don't know who that person is. So in this particular structure, we have the name given as propanol. Propanol, prop here is indicating 3 carbon atoms. So prop is indicating 3 number of carbon atoms. So we have 1, 2, and 3. Like we said before, ONE is indicating the ketone family. Please take note that ketone is always formed in the middle. That is why we have an alkyl group bonding to carbon, which is double bonded to oxygen, and single bonded to any alkyl group. When you have R single bonded to carbon and then double bonded to oxygen, but instead is found at the end, this is no longer the ketone family, but the aldehyde group. So for ketone, it is always the carbon double bonded to oxygen is always in the middle. So to proceed with this, we would have that our carbon double bonded to oxygen is in the middle. So that is just all we have to do in the structure. The next thing to do is to add our hydrogen atom. Note that carbon forms 4 bonds. So this first carbon is bonded to 3 hydrogen and 1 bond is bonding to carbon. So the last carbon is bonding to 3 hydrogen and then bonding to this. So we can see that the first carbon has 3 bonds, is complete. The second carbon has 1, 2, 3, 4 bonds, is complete. The third carbon has 1, 2, 3, 4, is also complete. So the condensed structure of this particular name is CH3, CO, CH3. So this is the condensed structure of propanol. So you can either go with this particular structure or this. Either way, you're correct. So on the second name, we have 3-hydroxy 2-methyl butanol. Please, like I said before, first thing first, identify your longest continuous carbon chain, which is but in this case, BUT. And like I said before, but indicates 4 number of hydrogen of carbon atoms. So, and it's butane, so it's indicating that these carbons, these four number of carbons are single bonded to each other. And then next thing to do is to identify your functional group, which in this case is OL. OL is an indication of the alcohol functional groups. So alcohol is OH. And then please, when you're drawing the structure, first thing first, identify the longest continuous carbon chain. Your functional group, before you go to the substituent, please go to the substituent before you start adding your hydrogen. It is when you are done with your substituents that you see which of the carbon atom that is not complete. That is when you begin to add your hydrogen. So we have identified the longest continuous carbon chain. We have identified the functional group, which is OH. And then the next thing to do is to identify the position of our functional groups. Since we have added OH at this position, then this will be our carbon 1 because this is taking priority over everything in this compound. So if this is our carbon 1, this will be carbon 1, 2, 3, and then carbon 4. So on carbon 3, we have a hydroxy. Hydroxy is an OH coming, alcohol coming as a substituent. So we have OH on carbon 3. And then on carbon 2, we have a methyl group. So this is our carbon 2. We have a methyl, CH3. So that's all the substituents we have in this particular structure. So the first carbon is bonded to one carbon. It has just one bond. So it needs 3 more hydrogen to complete. This is bonding to 1, 2, 3. So it needs just 1 more hydrogen. This is bonding to 3. It needs 1 more hydrogen. This is bonding to 2. It needs 2 more hydrogen to complete its shell. Please take note of the fact that this particular name here is not the IUPAC name of this structure. When you are going with the IUPAC name, if this structure were to be given, and then you have to write the name of this structure, first of all, count your longest continuous carbon chain, which is 1, 2, 3, 4. Next to do, identify your functional groups. In this case, the functional group here is OH, and then we have 2 OH, so that's going to be a diol. But then you have to number your longest continuous carbon chain in such a way that your 2 OH will give you the least possible numbers. So if you go with this numbering, you are going to have 1, 2, 3, 4 carbon atoms. If you go with this numbering, you have 1, 2, 3, and then 4. So on carbon 2 and on carbon 4, we have OH. Carbon 2 and carbon 4, we have OH. Going with this number, we have OH on carbon 1 and carbon 3. So, going by the least possible numbers, 1 and 3 are the least possible numbers. So, our substituent is only CH3 on carbon 2 because it is on carbon 2. We are going with the upper numbering. So, our CH3 is on carbon 2. So, the name of this, the IUPAC name of this compound is 2-methyl 4 carbon atom is but. So that's butane. On position 1 and on position 3, we have our OH. So that's 2-methyl butane 1,3-diol. So this is the IUPAC name of this particular structure, but instead it was given in the question as 3-hydroxy 2-methyl-butanol. So if you follow this pattern, this is the structure, but the IUPAC name of this structure is 2-methyl-butane 1,3-diol. So that is all for the second example. For the third example, we have our longest continuous carbon chain to be 1, 2, 3, 3 number of carbon atoms. Please, if you don't have any idea, like if you find it difficult to name condensed structures, anytime you're given a condensed structure, first of all, try to split the structure into the simplest form that you can name it. So, let's say the first carbon here is bonding to 3 hydrogen. The second carbon is bonding to 2. And then the third carbon is triple bonded to nitrogen. When you have a carbon triple bonding to nitrogen, you are going to have the nitrile group. So please take note of the fact that carbons form 4 bonds and then nitrogen forms just 3 bonds. Nitrogen cannot form more than 3, it cannot form less than 3, except if it is an ion. So carbon in the first case here is bonding to 4, in the second case is bonding to 4, in the third case is bonding to 3 here and 1, making 4, while nitrogen is bonding to 3. So like I said before, when you have a carbon double bonded, triple bonded to nitrogen, you are going to have a nitrile group. So for you to name a nitrile, you do count the total carbons that you have plus the last carbons triple bonded to nitrogen. So the name of this particular compound becomes 1, 2, 3 number of carbons, which is prop, and then you are going to name it using the alkane pattern. So this is propane nitride. The name of this particular structure becomes propane nitride. So that's all for number 3. For number 4, we have the longest continuous carbon chain in this particular structure to be 1, 2, 3, 4 number of carbon atoms. That is our longest continuous carbon chain. The next thing we have to do for us to name this particular structure easily is for us to identify the functional group in this particular structure. And the functional group taking priority in this particular structure is the alkane because of the double bond. So because alkene here, the double bond here is taking priority over everything in this compound, we are going to number the structure in such a way that alkene will have the least possible number. So if we start with this, we are going to have 1, 2, 3, and 4 number of carbon atoms. So on position 1, we have our double bond. But then on position 3, we have a methyl, and on position 4, we have 2 halogens, specifically the fluorine carbon atoms. So we know that we have fluorine here and we have methyl. So F comes before M. So you're going with the alphabetical pattern. So on position 4, on carbon 4, we have 2 fluorine atoms. So that's going to be 4 and then comma 4 fluoro. Then on position 3, we have a methyl. Please, before we go further, take notes. When you have 2 same substituents, it's not just going to be 4,4, like in this case, it's not just going to be 4,4 fluoro. It's going to be 4,4 difluoro. Because we have 2. Supposing we had 3, it would have been 4,4,4 trifluoro. But we have 2, so it's going to be 4,4 difluoro. Then on position 3, we have a methyl. And then the longest continuous carbon chain is 4 carbon atoms, which is both. But then on position 2, on position 1, this is our first carbon atom. We have a double bond, so it's going to be both. We're going to indicate the position of the functional group, in this case, the alkene family. So it's 4,4 difluoro, 3 methyl boats, 1 ene. The ene indicating the alkene family because of the double bond. So on question 5, we have the name given, and the name is 5-methyl-2-hexane. 5-methyl-2-hexane. So the first thing to do, you identify your longest continuous carbon chain, which is hex, and hex means 6 number of carbon atoms. So we have 1, 2, 3, 4, 5, and 6. So we have 6 number of carbon atoms. But then on position 5, we have a methyl. And then 2 here is indicating that on position 2 we have a triple bond because of the alkyne family. The functional group in this case is alkyne. So on position 2 we have a triple bond, and on position 5 we have a methyl. So instead, the name of this compound would have been 2,2,5-methyl hex 2-ine, YNE, because of the alkyne family. So this is indicating 6 number of carbon atoms, and then 2 here is indicating that on position 3 we have a triple bond, the YNE alkyne family. So if we are to go with the lower number, this is carbon 1, 2, 3, 4, 5, and 6. If we are going with the upper number, this is 1, 2, 3, 4, 5, and 6. Please know that you can go with either of these, but any of them that you choose to go with is going to be what you are going to use throughout. If you are going with the lower numbering, then you are going to eliminate the upper numbering. If you are going with the upper numbering, then you're going to eliminate the lower numbering. So in this case, let's go with the upper numbering. So we'll eliminate the lower numbering. So these are carbon 1 in this case, not this, because these are carbon 1, because we want to consider it as our carbon 1. So on position 2, we have a triple bond, YNE, alkyne family. So these are carbon 1, these are carbon 2. So on carbon 2, we have a triple bond. And on carbon 5, we have a methyl, which is CH3. So we are done with our substituents. The next thing to do is to add our number of hydrogen to make the structure complete. So on carbon, this carbon here has just 1 bond. It needs 3 more hydrogen to complete its outermost shell. This has 3, it needs 1. This has 2. You need 2 more hydrogen to complete it. This is complete because this 1, 2, 3, 4 for this particular carbon is complete. It's also complete because it has 1, 2, 3, and 4. And then this particular carbon has just 1, so it needs 3 more hydrogen to complete its shell. So that's all for number 5. For number 6, the name is given as 3-methoxycyclohexane 1-amine. 3-methoxycyclohexane 1-amine. So the first thing to do is to identify our longest continuous carbon chain. And in this case, it is not a linear structure instead. It is a cyclohex. Cyclo indicating a ring structure and hex indicating 6 number of carbon atoms. So because it is a ring structure, we are going to have a ring 6 carbon structure. This is carbon 1, 2, 3, 4, 5, 6. So the next thing to do is to identify our functional group, the one taking priority in this compound. So on carbon, the functional group taking priority in this compound is amine. Amine is a nitrogen attached to a carbon, single bonded to a carbon. It is different from a nitride because for a nitride, it is carbon triple bonded to nitrogen. But for amines or amides, it is carbon single bonded to nitrogen. But please know that amines are different from amides because amides, the carbon single bonded to the nitrogen is also double bonded to oxygen. While for amine, the carbon single bonded to nitrogen can be bonded to 3 other hydrogens or hydrogens and other carbon atoms, but it is never bonded to an oxygen. So that's the difference between amines and amides. So on our functional group taking priority in this case is the amine. So this is a cyclo ring structure. So we can choose any position to be our carbon 1. So Any position in this case can be our carbon 1, but as far as we choose it to be our carbon 1, we are going to start numbering from there. So we can either go with the clockwise or the counterclockwise numbering. So let's say, for instance, we choose this position to be our carbon 1, and we know that there is a carbon here, so it's double bonded to this nitrogen. So like I do say, don't go ahead adding your hydrogen first. Wait until you're done adding your substituents. So this is our carbon 1. If we are going with this numbering, this is carbon 1, 2, 3, 4, 5, and 6. If we are going with this numbering, this is 1, 2, 3, 4, 5, and 6. So let's go with this numbering, 6. So next to do is to add our substituent. On carbon 3, we have a methoxy. A methoxy. When you have an oxygen attached to an alkyl group, that is when you're going to have an alkoxy group. And methoxy is one of the alkoxy group. So when you have an oxygen attached to an alkyl group, that is when you have your alkoxy group. Alkyl groups are derived from alkanes by the removal of one hydrogen atom. So let's say if we have the first member of alkane, CH4, which is methane, and then we remove one hydrogen from here, we are going to have CH3. So if we have CH3, this is methane from the alkane, and this is methyl from the alkyl family. And then with the addition of O on the alkyl family, for in this case, oxygen with methyl, OCH3, we are going to have a methoxy. Same thing applies to the second member of alkane family, ethane. Ethane, with the removal of one hydrogen, you're going to have ethyl. With the addition of oxygen on ethyl, you're going to have ethoxy. Same applies to propane. With the removal of hydrogen from propane, you're going to have propyl. With the addition of oxygen on propyl, you're going to have propoxy. So that is how an alkoxy is being formed. So in this case, we have a methoxy, and a methoxy is an oxygen added to an alkyl group, and the alkyl group in this case is a methyl. So an oxygen added to a methyl is a methoxy, and in this case, this is a methoxy. So the methoxy is on carbon 3. So on carbon 3, we have a methoxy, and this is our carbon 3. So we have our methoxy. If it were to be ethoxy, for instance, this is ethoxy, OCH2, CH3. Removal of one hydrogen atom from an alkane family. For instance, ethane, you're going to get an ethyl. And then with the addition of oxygen to an ethyl, you're going to have an ethoxy. But in this case, we have a methoxy. So it is the addition of one oxygen to a methyl group. So that is our substituent on carbon 3. So we are done with all our substituents. On carbon 3, we had only a methoxy. So we are done with the substituent. The next thing to do is to add your hydrogen atom. Please remember that nitrogen is having 3 bonds. So we have just 1 bond here in this nitrogen. So it needs 2 more bonds to complete its shell. So the structure here is nitrogen double bonded to one hydrogen, another hydrogen, and then single bonded to a cyclohexane. So this is all about the structure. You can also write this as NH2, also the same. So this is all for trimethoxy which is this cyclohex-1 amine. So the position of the amine is on carbon 1, indicating the parent name. So this is the structure for trimethoxy 3-methoxycyclohexane. So now we are on carbon, on number 7. We have a benzene bonded to a CH3 and then bonding to 3NO2. When you have a benzene bonding to CH3, you are going to have a toluene. So when you have a benzene bonding with a CH3, you are going to have a toluene. So this is our carbon 1 because it is what gives benzene the parent name of toluene. So if we start with this, we'll either go with the clockwise or the counterclockwise numbering. So if we go with the clockwise, this is carbon 1, 2, 3, this is 3, 4, 5, and 6. So we have a subsequent which is nitro on carbon 2, on carbon 4, and on carbon 6. So let's go with the counterclockwise numbering. We have this 1, 2, 3, 4, 5, and 6. Going with the counterclockwise, now we substitute on carbon 2, on carbon 4, and on carbon 6. So either with the counterclockwise or with the clockwise counting, we'll have 2, 4, 6. So we can pick any of them. So we have on position 2, 4, and 6, we have 3 nitro. So the name of this compound is 2, 4, 6 trinitro toluene. So that is the name of the ring structure, the benzene ring structure in number 7. So for number 8, we have a condensed structure given. Like I do say, if you have a ring structure given and then you are having 1 or 2 issues on how to name a condensed structure, first of all, split the structure into a simpler form for you to be able to name it. So this is our first carbon. It's bonding to 2 hydrogen and then it's bonding to another carbon which is bonding to 1 hydrogen and is bonding to CH3. This is bonding to this particular carbon bonding to 1 hydrogen and is bonding to CH2. Okay, let me write it. And is bonding to CH3. So we can see that the first carbon here is not complete. So while writing, I did a mistake here. So this was to be carbon bonding to CH3 and then bonding to this other carbon. So on this particular carbon is bonding to 1 hydrogen and then CH2. The structure here is also, the bond of this particular carbon is also not complete. So we have a double bond also there, but this carbon is complete. So the first carbon is bonding to 1 hydrogen and is double bonded to this carbon. This particular carbon is single bonded to CH3, a methyl group, and is single bonded to this carbon, which is double bonded to this particular carbon. And this particular carbon is also complete because 2 hydrogen and 2 bond here, making it 4. This has 3 plus 1 here, making it 4. So we can see that when you are given a condensed structure, it is not necessary that the bond you have in that compound will only be single bond. But when you try to split a condensed structure, you'll find out that some carbon are not completely bonded, just like here. So you have to identify the fact whether the carbon in that position is double bonded or is triple bonded or is single bonded. So just like we did here, we are able to identify that this carbon has just two hydrogen. So it cannot be single bonded to this carbon. It has to be double bonded for it to complete its outermost shell. Carbon needs 4 electrons to complete its outermost shell, and it has to always have 4 bonds. So with the 4 bond here, this carbon is complete. With the 4 bond here, this carbon is complete. With the 4 bond here, 1, 2, 3, and 4, this carbon is complete. Here also and here. So now you'll be able to name your structure. So after you have split your condensed structure, the first thing is to identify your longest continuous carbon chain. And then in this case, we have this carbon 1 going with the lower numbering 2, 3, 4, and 5. This is the lower numbering. So with the upper numbering, we have 1, 2, 3, 4, and 5. You know that your what is taking priority in this particular structure is the alkene family because of the double bond indicating the alkene family. So your numbering should be in such a way that the 2 double bonds you have in this particular structure will have the least possible numbers. So here we have on carbon 1, we have a double bond, and on carbon 3 we have another double bond going with the lower numbering. Going with the upper numbering, on carbon 2, we have a double bond, and on carbon 4, we have a double bond. So that's going to be 2 and 4. So you can see that going with the lower numbering, you're going to have the least possible numbers, 1 and 3. So you're going to eliminate the upper numbering and go with the lower numbering. So did we have any other substituent? Yes, we have a substituent on carbon 2. So on carbon 2, we have a methyl. Carbon 2, we have a methyl. Did you have any other substituents? No. And the longest continuous carbon chain is pent. And then on carbon 1 and on carbon 3, we have 2 double bond. So that's going to be 1,3 diene because we have 2 of the alkane, which is the double bond. So that's the name of the structure is 2-methyl pent 1,3-diene. So on number 9, we have the name as NN-dimethyl both 3-2-amine. So firstly, identify your longest continuous carbon chain, which is both 4 carbon atoms, 1, 2, 3, and 4. So on carbon 2, you have amine, and on carbon 3, we have En, En indicating the alkene family. So going with the lower numbering, 1, 2, 3, and 4, on carbon 2, we have amine, which is carbon single bonded to nitrogen. Like I do say, forget about your hydrogen until you're done with your substituents. So on carbon 3, we have En, that is an indication of double bond. So these are carbon 3, double bond. So is there any other substituent? Yes, NN-dimethyl. NN is indicating that we have 2 methyl group attached to the nitrogen. So here we have CH3 and then another CH3. Now the bond of nitrogen is complete because it needs 3 bonds, and we have one N-methyl and another N-methyl. So that is just all for the substituent you have in this particular naming. So the next thing to do is to add our hydrogen. Here has 1 bond, so we need 3 more hydrogen. This has 3, we need 1 more hydrogen. This has 3, 1, 2, 3, we need 1 more hydrogen. This has 2, we need 2 more hydrogen. So that is all for number 9, which is NN-dimethyl both 3-2-amine. So lastly, number 10. So The first carbon is bonded to 3 hydrogen. The second carbon is bonding to CH. The third carbon is bonding to CH, which is also bonding to CH2 and is bonding to another CH2. It's also bonding to another CH2. It's bonding to another carbon, which is bonding to CH3, and then it's bonding to CH. So let's check our first carbon. Our first carbon has 1, 2, 3, 4 bonds, is complete. Our second carbon has 1, 2, 3, it's not complete. Our third carbon has 1, 2, 3, it's not complete. So we need a double bond here to complete for the second and third carbon. So our fourth carbon has 1, 2, 3, 4, it's complete. Our fifth carbon 1, 2, 3, 4 is complete. Our seventh carbon 1, 2, 3, 4 is complete. Our eighth carbon is 1, 2, 3, it's not complete. So what if we decide to add a double bond here? This carbon is 1, 2, 3, 4, is complete. What about the last carbon? This carbon is double bonded to this carbon and is single bonded to hydrogen. 1, 2, 3, and it's not complete. But then in the condensed structure, we were given just 1 hydrogen. So in simple terms, this could be a mistake from typing, because actually if this were to be a double bond here, this carbon, the last carbon, will have 2 hydrogen. But if this were to be a triple bond, then there wouldn't have been a CH3. So in either case, it's either there's 2 hydrogen in the last carbon or there's no CH3.